Hey everybody, I'm Jacob Coffey. I work at the Python Software Foundation during the day, working on infrastructure and engineering efforts and open source. I help maintain a web framework called Litestar. And today I want to talk to you about PEP810. It's about explicit lazy imports. You kind of get that with implicit, or you can kind of do this now by stuffing an import inside of a function and things like that. But with PEP810, now that it's approved in 3.15, when it finally releases, you'll now have the ability to explicitly declare an import at the top of your file as lazy. So, and I'm going to take this through the lens of a very, very real but a fake bread baking business, because why not? So we have the bakery. Just a quick overview of what we'll cover. I want to cover why this is a big deal. It's about like the Python startup time. That's an issue if you've built big CLIs or applications, especially at HRT and similar giant companies like this. They run into this problem quite a bit. Explain how 8.10 works a little bit, and skip the live demo that's on this because it terrifies me to do a live demo after my last talk. And we're going to look at real-world impact from companies like HRT and Meta, and then use cases for this beyond just CLI tools. This talk is just about my bread business that uses a CLI to order and process things for their bread business. And then a migration guide, a small migration guide, how to actually use this and not just blanket lazy import everything, because you don't want to do that. So the problem here you see is that Python startup time is expensive. So here I'm running a time command. This is like just a quick way to see how fast my current CLI, just by running the help flag to get like what my options are in the CLI. And it's 234 milliseconds just to show like 2 lines, and that's kind of crazy, especially if you've used like Go or Rust CLIs. They're quick, instant. The eager import model right now loads like the entire world at startup, and that's super, super slow. It imports all the modules immediately, unless they're nested in function calls, like I mentioned a minute ago. And that's even if you don't use those in the code path. So it's also a problem with memory bloat, because you're loading all of the world. So all of this loaded in imports, they stay in the memory. And for example, with Meta's internal fork that has lazy imports already, they saw like a 30 to 40% decrease in startup time, memory reduction. There's also a cold start tax, so if you're doing serverless things, that is a big deal with serverless or workers, or even if you're doing things like test suites that grow and grow and grow, you're going to pay that tax there. And then you have things like the if type checking block. It's an ugly hack, and so this would avoid all of this too. So Meta's analysis showed that their fork with this feature already built in had a 50 to 70% decrease in startup reduction time, 30 to 40% memory savings, and PySide itself showed a 35% startup improvement, which is great. So what it is and why we need it. So PEP810 imports a module when it's first accessed, so not when it reads the import line. So if you have an import that's lazy, it'll just defer it until the execution of that module, which is really helpful. And you get that nice explicit syntax. So the syntax, we'll cover this in a second, is just lazy import this thing instead of just import this thing. So good news is that PEP810 was accepted. You can now get it in the 3.15 beta 1, I think, that released a week and a half ago. And you could try it out yourself. And this is kind of following Python's philosophy of explicit is better than implicit, so it's right in line with that. So it's all good. So I can show you a little bit what the syntax looks like. As you can tell, I'm very bad at clicking through my slides. Sorry about that. So the normal way, we have our normal.py file that's just as you would do today. I have from breadctl import bake, import delivered, and import inventory. If I call that help flag again, it's gonna call all of those and it's gonna load them. And for my bake example here, it's using iter tools and collections, which are built-ins, but deliver makes a web call because you want to order your bread from the CLI, because why not? And that uses HTTPX, and then the inventory, well, that's a SQLite thing. So you're loading all these modules when you're just trying to get help to see what your options are, and well, it's really slow. With the lazy thing, this is all you got to do, is add the lazy keyword to the front of your import, and so you lazy import from, or lazy import breadctl.bake as bake, and so I've just changed some things around, but really you just need that lazy keyword. All right, so how it works, basically the lazy import foo, instead of having this like real thing in the namespace, it's like a lazy module proxy. And so when you say lazy import HTTPX, it's like a fake import, so it's like a very lightweight proxy object. There's no import yet. But no file I/O happens, no code execution happens, and that just lives in the namespace where HTTPX would normally be. So we have this proxy sitting in our namespace now because we've lazy imported it, and it's just kind of sitting there waiting. Again, no network code is loaded, no dependencies are pulled in, and your startup stays fast because nothing heavy has happened. This is why the help can be quick, because it doesn't touch the proxy until you need it. So it's wonderful. All right. So the moment you actually call HTTPX, in our example, like you would use httpx.get, that function or method, Python intercepts the attribute access, and it does the real import. The proxy object that we just talked about, it's transparently replaced with the real module, and this is good. Your code never knows the difference. Well, it can be good. It can also be terrible. I'll explain that in a minute. But the key insight here is that if you never access it, it never loads, and that's the whole trick. It's super simple. And I will be remiss to say that I am an expert in this. I'm doing this talk because I didn't know what this was about, and someone told me that the best way to learn something is apparently to give a talk on it. And that kind of forces you a couple of weeks before you give your talk, or maybe a day before, to really dive deep into what it is, and then you kind of understand it better because you can talk about it to a group. And I've given this talk maybe 4 or 5 times now, so hopefully I really understand it. All right, so how it works, the complete picture again, you parse the file, creates the proxy waits dormant, and then when you access it, the real import is popped out, and then you can actually use it, and that's when the cost comes to you. But if you don't, it's good. The help command stays fast, or all of your other examples. The help is my example here. They all stay fast, and things like tab completion and like subcommand routing, they also all fast. So here's our live demo. Wow, great. So live demo, right? So you can see though, this is the only difference in breadctl and breadctl lazy here is that I added the lazy imports. There's no change, and you can see like a pretty big reduction here. And this is my silly CLI example. Obviously, if you're using Litestar framework in production with 500 files, then it's going to be a lot better. Or if your PyTest suite is like gargantuan, it's going to be a real help, and that's really helpful. So here, it's a 30% difference just from one change. That's pretty great. And we're going to skip the rest of this because it's not a real live demo. I lied to you. So some more like benchmarks results, and all of this is in a repo, and you can kind of poke through it, but it's not great code, so don't judge me. But it just showcases the power of this PEP, the feature. But with our help command, we saw that 23%, my math is a little bad, 23% faster run on that call. Module import time, 26% faster. And then the inventory command stayed the same in my test. I'm not convinced that I did that properly, but some things won't get faster just due to their nature. So some real world impact. I talked about HRT and Meta using this already, but it's not theoretical because we're part of the PEP authors. They, I think there's like 5 or 6 of them, and they're from all over. So you can see some from HRT and Meta and these big companies that have been using it, so they know like the context of like the good decisions to make, and so we're bringing that in to use for everyone. So Meta on their Cinder fork saw a 70% startup reduction, 40% memory savings. HRT has been using the lazy importing for years, and PySci, which is cute, for Python, their bindings saw a 35% startup improvement. That's great. And so these aren't really experiments, so you know that when 3.15 rolls around to your code base, that it's not going to be some sketchy thing. Not that the core team, the CPython core team would release something like that, but you know that it's already been battle tested, and that's really, really nice. So where else can you use lazy imports? Obviously, my example is very silly in my bread CLI, but I mentioned earlier that you don't have to have type checking guards anymore, which I think at least makes your file, your module cleaner, if anything. You don't have to have if type checking and then a bunch of imports that are indented because of that hack. You don't have to have that anymore. Test suites, so unit test and PyTest, the discovery phase is a lot faster because it's only importing the things that it needs at the time it needs them. Plugin architecture, so Litestar, for example, uses a lot of plugins as like a plug and play, so it's like in between Flask and in between Django. So there's a lot of options, but you can reach for them. And when this is available in 3.15, we will be able to do the plugins and not like hamper your code, so it will err more towards the Flask side of being lightweight, unless you use the plugin and it's called. Also in the serverless world, so for Lambdas and Cloudflare workers, things like that, you see like 50 to 70% faster cold starts, which is important in serverless, I hear. And then in memory constrained environments, like a small chip, it's a big memory reduction. So containers or edge devices, like in a factory somewhere that are really crappy hardware, you're going to get that benefit too. And then CLI and GUI, obviously that's our bread and butter, but things like Django's manage.py, which sometimes, like for python.org, something that I work on, it takes quite a while to print out the available commands, and this will be great to try it out in the real world, or your PySide apps and other things like that. So how do you do it? And should you lazy import everything? No, but let me tell you why. But first, let me tell you how you should get there, and then we'll go back to why not everything. So, at least what I did is in the breadctl repo, you'll see that there's a breadctl module and a breadctl -lazy, and it's the same code, but one uses lazy as the import. Super simple, but I profiled the existing module with just this simple Python-X, big X import time, and then ran my imports to see like what's my biggest consumer of startup time, and then look for the cumulative column, and then see like anything that's maybe like heavy hitters, things like pandas and NumPy and anything that's like bigger than 50 milliseconds. I mean, just pulling a number out of thin air here, but anything that could have a big impact, reach for those first. Don't just like find and replace, but find that and apply it selectively. And then you can kind of start to see like the impact of that pretty immediately, especially if you have like 40 quick import things and like 10 heavy ones. If you just do those first 10, then you're like off to a really good start. One reason to not convert everything at once in testing, since the module level init happens at first access, you can see things that happen like you could lazy import something that just does not exist, and you won't know until you've deployed this. Maybe you test it and they're like, oh, it all works, but then something calls it. Maybe you deploy it to a web service, and it finally calls that lazy import, but the import doesn't exist, and you find out in production when it crashes, and that's no good. So that there is like a caveat to the lazy imports, because it does kind of hide that from you, since it's not being called eagerly. And then after that, so after you've done the testing, you've applied it selectively, and then you can measure your improvement with a tool like Hyperfine. That's what I did. Did like a few warm-up runs, and then you're off to the races. And your breadctl CLI goes very, very fast with much less memory. So start with things like that really you see like a big impact on. So for me, it was the help command. That was annoying, just to run -- help, and it takes, it's 234 milliseconds, but to me that's like forever. But start with these things that benefit the most. Maybe they're user-facing or internal, and don't optimize the code that needs it. But again, so the caveats, like I mentioned, since the import time or import things are deferred, you have those side effects like your login config or like DB connections. If you lazy import those, like bad things can happen, because if you don't have them in the right place, then your login config is not called, and so it's just the default login config, or your DB connection is not set because you have lazy imported it, and something that calls that needs the DB connection first, and now you're screwed because it's not there. So you can't always just lazy import everything. At the time of the last edit of this talk, which was about 10 minutes ago, but which is really bad timing, by the way, sidebar. I was out there thinking, oh, my talk's in 15 minutes, I can do this. I start working on it, and then 3 messages come in from the registration desk, and 1 from a sponsor, like, oh, this thing's broken, the connection for the Wi-Fi is down, and so I may be talking a little fast, but there's like a lot of fires out there that were just really unfortunate timing for me. One thing I've learned maybe is don't give a PyCon talk when you're in my shoes, at least this year. But thankfully we have a lot of volunteers, so session chairs, anyone else that's volunteered this week, super big thank you. Thank you for being here. Sidebar over. Okay, sorry. Where are we at? ADHD's really bad with me, sorry. The import errors are going to happen on first use. So maybe you missed something in the requirements, txt file, your PyProject TOML, and you have this lazy import pydantic, and you don't have it in your requirements, and so you don't know that, you forgot to add that there, and you're going to have an import error, and that's going to be hidden from you now. Very similar to the thing I talked about earlier. It's not always faster. It's best for conditional or optional imports, I think, right now, and then you kind of grow into it the more and more you use it. Some tips are test with super simple things like help to make sure you understand the impacts of it, and keep eager imports for always use modules like logging, and then document which imports are lazy, because future you at least is going to forget, and your team probably won't know about lazy imports as fast as you are. So kind of explain to them caveats and the benefits of this, and the foot guns that they could run into. And there's another feature or gate inside of the PEP that says, there's a few of these, but one of them is that you can't actually lazy import inside functions. I'm not sure why would you do this, but it's not an option. So this is outdated, my bad, but the reference implementation is in a CPython fork. It's CPython, or no, it's the organization on GitHub is github.com/lazyimportscabal, and then /CPython is the repo. It's just a fork of the CPython with that implementation, but it has since been pushed into the CPython mainline beta, so you can get that. I think the latest alpha had that, and then now the beta's released, so it's available for you to use. So here's some design principles, kind of like reasoning about this. Explicit, that's an obvious thing. Using this keyword makes it very, very clear that it's going to do this thing. And as long as you know what lazy does and the drawbacks and the benefits of it, you can have like a good way to reason about this thing and why you should use it. And it's nice to just see like your code editor highlight when you're in ed, because everyone here uses ed, right? Why it would, when it highlights the lazy, it's like, oh, it's like, this is a thing. There's no surprises or anything like that. It's local, so it only affects that one import, so you can have all of your eager imports just like you have them, and then on one line, it's just going to affect that one lazy import, and then also granularity, so it's kind of in the same vein, but you can mix and match them pretty freely, which is great. All right, so resources for you if you want to read up on the PEP. This goes way into detail about the Python side, but also the C code, and it talks about all kinds of great things like reification and some crazy things that way smarter people than I figured out. And if you like that kind of stuff or want to learn more about this, you can check out the PEPs doc. It's peps.python.org, and then find it there, PEP810. You have my demo repo. Please don't look at that, but if you want to, it's at github.com/myname/breadctl. And then I did update this one. It's in the beta, so you can actually use it just by installing that with Mize or UV or whatever you use. And then I mentioned earlier that I used Hyperfine to benchmark the things, and it's a great tool. I love it. We use that on PyPI and different projects all the time, and we really like it. So, perfect. Thank you. Now you can go make your Python very, very fast. I'm not going to wait super long for questions because, as I mentioned 4 minutes ago, the world is on fire out there for the PSF team. Okay.
Hi.
Hello.
I've been thinking, with this level of granularity, when you put lazy on each import line, it's possible that a module can be imported both lazy and import in different places. And
yes,
like there are some cases when you know that databases initialization should be eager, and it's like some stateless modules can be lazy. It's okay, but there's gray area modules when you don't know for sure, and it's big enough, and you don't know the code base. Do you need both lazy and eager testing for this kind of modules, or like how do you keep only like single way of testing a module and be sure that it's safe?
That's a question I've never been asked before in all my times of giving this talk. That's a great question. It seems very verbose to have to do the lazy and eager import testings, but that might be a good way. That's not going to be a good answer. My answer is I don't know. Great question, but I think it would be safest to do both of the eager or lazy testing in that like transitionary period. And then you can clean it up after you're like, oh yeah, this is okay, like this way, or like, no, something blew up. We have to keep this eager, or refactor the thing that like makes it have to be eager to fit in the lazy model. So, yeah.
Thank you.
You're welcome.
Hey, thanks for the talk. So have you looked at how circular imports are handled? So if you have one module, you import lazily, and then you do the other part of the circular import non-lazily. How does that work?
So if you lazy import a thing that would cause a circular import, it's much like lazy importing a thing that does not exist, or a requirement or a dependency that never got loaded. You won't find out about it until the bad thing happens, until whatever caused that circular import happens. It'll just blow up in production. Yeah. So it certainly defers it, but it defers it in like every way, good or bad. So that's a foot gun there.
Gotcha. Thanks.
Mm-hmm. Perfect. All right. Thank you all so much. See you out there in the halls.